Okay, so welcome to another episode of How Do We Pass Our, what was that? Oh yeah, Common Core Algebra Regions. I'm still sleepy. Alright, so today we're going to continue with the quadratics, and we've seen how to graph parabolas, how to find the axis of symmetry, and how to identify the vertex. Now we are going to explore an additional part of it. This is called the vertex form of quadratic equations, which is basically one of the things that appears on the regions. So after this, you should have mastered this topic. Alright, so what is vertex form? Well, vertex form, they call it vertex form for a reason. Just like in linear equations, they call it slope-intercept. That means that you can identify the slope and the y-intercept. Well, in here, you'll be able to identify the AOS, which is the axis of symmetry, and the vertex of your quadratic equation. Remember, the quadratic equation, when you graph it, it looks like a U, right? Like a parabola, like this. Something like that, right? If you could see it. Or it should look something like this. Alright? If it looks something different, then it's not a quadratic equation, it's something else. Alright, so let's start. On the last episode, we saw how to complete the square. Well, this is 80% the same, but 20% different, okay? And it's different because they have made it different. Anyways, let's get into this. So it says, convert into vertex form. So we have y equals 2x squared plus 36x plus 170. Alright, so how do I do this? Well, the first thing you want to do is you want to isolate the square term, okay, and the linear term. The linear term is the one that has a 1 as an exponent. So 2x squared plus 36x, okay, plus, you're going to put a box in there. Don't worry about it. We're going to get to that. Then we're going to close parentheses. So you see, I isolated the square term, the x, and then I added a box here. Well, now that it's isolated, then I still write the constant term, but now I'm going to subtract what I added here. What? Well, yeah, I mean, it's an equation. You got to keep it the same. So if you add 4 and you subtract 4, there's no harm done, right? Yes? Cool then. Okay. So from here, from here, I want you to extract the numerical value, okay? Because if I was to ask you, what is the GCF here, you would say 2x. No, I want you to just subtract the numerical value. Yes, they have a 2, okay, a factor of 2 in common. So extract that factor of 2. You see, still the same thing as factoring. So now, what do you have left if you take out the 2? Well, you get left x squared, okay, because 2x squared divided by 2 is x squared. And then you get, instead of 36, you get 18x plus box, okay, equals 170 minus box. You see the 170, nothing happened to the 170. Alright, let's move on. Take half of the, wait, that's completing the square. Yeah! Take half of the linear term, which is 18, now becomes 9, and square it, so it becomes 81. Now add it here, and also subtract it from the 170. But this is one thing that you have to be very, very, very careful about. You have a factor of 2 outside your trinomial here. Yes, this is 81, but in reality, are you really adding 81 or are you actually adding 162? That's why. You understand? So don't forget about this number outside. Alright, so then this is 170 minus 81 times 2. See? 81 times 2. Oh, Max, you're nice. Yeah, coach again. So, now, remember when we saw the PST, the perfect square trinomial? Okay, this, as soon as you take half and you square it, you form a perfect square trinomial. Meaning that when you factor it out, you're going to have two binomials that have the same terms. In other words, x plus 9 times x plus 9. And since we already been through that, then I don't need to explain, oh, x plus 9 times x plus 9. No, x plus 9 squared. And then plus This could be a minus, this could be a plus. It depends on what we get here. So here I got 170 minus 162. That's 8. So that's it. All right, so what about it? Well, then you write y equals 2 times x plus 9 squared plus 8. And what this is called the vertex form of a quadratic equation. Why? Because it is easy, without graphing it, it is easy to determine what the axis of symmetry is and what the vertex is, and also what the y-intercept is. Wait, I'll tell you. Alright, so let's start. The vertex here will be the opposite of this number. Okay? Let me zoom in, maybe you can see better. Zoom in, I said bex. Okay. The axis of symmetry, the equation of the axis of symmetry will have the opposite of this. So in other words, the axis of symmetry will be x equaling -9. And now the vertex. What would the vertex be? Well, the vertex will be the following. Vertex. The vertex. Oh my God, Becker, forget about it. You have it already. Yeah, that's what happens when you just wake up. So axis of symmetry, x equals 9. That means that when the parabola, okay, when you sketch the parabola, the equation of the axis of symmetry, the line that chops the parabola in half, will be x equal -9. Okay, so it's gonna be somewhere. No. Let me see. How do I do this? How do I do this? How do I do this? -9. How do I make -9 appear here? Oh, I know. Like this. So this is 0. Let's say this is the y-axis. Okay. What am I doing? This is the y. Oh, nice. You cannot see. Ha ha ha. Very funny. Okay, right here. So the axis of symmetry will be at -9, which is right here. Okay, x and y-axis. Anyways, I'm not good at sketching, but you get the point. Now the vertex, in this case, okay, will be right here. Okay, the bottom part of the parabola. The vertex will happen at -9, comma, +8. So this is a very awful sketch, but this is where it would happen. Anyways, you saw how it goes. Alright, so now I'm going to give you basically the steps on how to convert the quadratic equation into vertex form. I hope my steps are very accurate. Alright, so what you're going to do right now is you're going to copy the steps. Okay? Okay, so those are the steps. So converting, right, to vertex form. First, separate the x squared and the, I don't know if it's going to be plus or minus, right? The linear term. So you separate them from the constant term, which is basically a number. Okay. Then, if possible, extract the numerical value of the common factor between x squared and x. In other words, remember when we took out the 2, that was the numerical value on the previous problem. Now, it says, take half of the linear term to form a perfect square trinomial. And also subtract it from the constant term. Keeping in mind the term that you took out. Okay, the 2, the 3, whatever you take out, keeping in mind that you're gonna have to multiply that much when you subtract it from the constant term. Then form a square binomial and you're done. Your final answer should look like this. Y equals a times x minus h squared, okay, plus k. Where the opposite of this is your axis of symmetry, and these two form the vertex, either the maximum or the minimum. Okay, it depends on the coefficient of x squared. If it's negative, you're gonna have a maximum. If it's positive, you're gonna have a minimum. All right, so you copy this, and now let's get to business. Let's actually do some damage. Oh. Vertex form, here we go. And then I'm going to explain to you what does the vertex form do to the, well, actually, how does it help you to identify certain parts. So let's start with a simple one. So y equals x squared plus 16x plus 71. Okay? And now, so how am I going to do that? Well, isolate the square and the linear term, right? So I'm going to forget about the y for a minute, and I'm just going to concentrate on this. So I'm going to separate them. So I'm going to have x squared plus 16x, and then I'm going to put a box here. The box is because for when I take half of this and square it. Plus 71 minus the box. Okay, plus the box, minus the box, no harm done. Now let's see. Is there a common factor here? Yeah, a 1. I'm not going to write it, okay? The only time I write it is when I'm using the AC method, or the splitting the middle term method. So let's see now. My next step is to take half of the linear term and square it. So half of 16 is 4. Square? Wait, half of 16 is 4? No, half of 16 is 8. Square? Makes it 64. And then, is there a number here? No, right? So it's just 1. 1 times 64 is 64, so I just put 64 here. Okay? And now, guys, as soon as you did that, this turns into a PST, a perfect square trinomial. So then, what do you think I'm going to have here? X. What was the number that I squared? 8, right? See that? Now, what is 71 minus 64? Come on, tell me. Got it? Okay, so what do you get? 17, right? 17. Let me see. 17. No, 7. Oh my God. So it's 7, right? Okay. So what's going to happen now? Nothing. I'm done. Now I'm going to put y equals. Alright? And now look. The axis of symmetry is 8. Meaning that that's the line that's going to chop the parabola in half. And the vertex, okay, vertex equals, okay, negative 8. Because remember I said the opposite. Comma 7. That is the point where the parabola, since this is positive, the parabola is going to have is going to open upwards. It's going to be concave up. That means that it's going to have a minimum. So the minimum is negative 8 comma 7. And that is your vertex form. You want to do another one? Sure, let's do another one. Okay. Alright, 3. I'm going to do all type of problems so you can understand how to do this. So 3. Y equals negative x squared, okay, minus 14x minus 59. Okay, so we're going to isolate the terms. This time I'm going to do a little bit different, but it's still the same thing. So I'm going to isolate this. Okay, so we have this minus 59. Alright, common factor here. Listen, when you do that, try to maintain the x squared positive. So forget about the y for a second and let's just concentrate in here. So I'm gonna factor out the negative. What? Yes, please just go with the flow. I don't even know if I'm doing it right, but hey. So x squared, all right, and then plus 14, right? Because you wanna maintain everything intact, the same. Look, this gives you negative x squared, and this gives you negative 14x. All right. Now I'm going to add the box, plus box. Okay, minus 59 minus box. I know it's funny. Well, you take the same thing, so no harm done. All right. So what is the next step? Take half of the linear term and square it. Half of 14 is 7. Square 49. And I'm gonna do it to the other side, right? But remember something. I have something outside here. So what am I gonna take away here? I'm gonna take away negative 49. Because you see, you gotta keep everything the same. This is being multiplied by that. Okay. So let's see now. This creates a perfect square trinomial, which can also create a square binomial. So, what was the term that we squared? 7, right? So it's going to be x plus 7. All right? And now, let's see. Negative 59 minus negative 49. What in the world? Well, in reality, this... Oh, wait. Square. Okay. So, minus 10. Where do I get that 10 from? From here? Well, minus negative turns into a positive. So, negative 59 plus 49 is negative 10. I hope it makes sense. Okay? Alright then. So, now... we need to turn... Okay, so what will be the vertex over here? The axis of symmetry. Oh, by the way, this is negative 1, okay? Negative 1. So the axis of symmetry, the axis of symmetry will be negative 7. And your vertex will be negative 7, comma, negative 10. Because remember, the vertex form should look like this. A times x minus h square, okay, plus k. So, you worrying about this negative. Oh, why didn't you distribute it? No. This negative belongs to the a. In other words, this would be like negative a. Alright? Don't worry about that. This is correct. Alright? If you don't understand, make a comment. Or just ask me and I will explain or clarify this. Alright. Let's do another one. Oh, you found me! Oh, I caught you. Okay. Let's see if I can fit number 4 in there. I'm not sure. Alright, so I have x squared minus 12x minus 12x plus 46 equaling to y. Alright, let's see if we got the hang of this. So the first thing is to separate these terms, right? So I'm going to do it right away. Now, I'm going to forget about the y, and I am going to just concentrate on the terms. Alright, so do I have a common factor here? Well, the x squared is already positive, and they only have a common factor of 1. So yes, okay, let's pretend we took it out. Doesn't matter. I'm not going to write it anyways. And so, x squared minus 12x, and then plus box, okay, plus 46 minus box. Alright, so let's take half of the linear term. So half of 12 is, well, half of negative 12 is negative 6. And negative 6 squared is 36. Okay? And what you do to one side, you do to the other. There is nothing here that is going to multiply the 36, so we're Gucci. Alright? And now, this creates a PST, a perfect square trinomial. So then, from here, I can just write the following. My square binomial. So what was the number that was squared? It was not 6, it was negative 6. Okay? Half of negative 12 was negative 6. And then, plus, what is 46 minus 36? 10. That makes your vertex positive 6, comma 10. And your axis of symmetry, x equal positive 6. The line that's going to chop the parabola in half. Beautiful. Okay, my God, we're going great. Jesus Christ. Nah, what do you mean? We're doing great. We're really behind on this thing. But I need to do this. Alright, another problem. Man, I hate not having the answers with me, but hey, it doesn't matter. Alright, let's do something that also has, oh yeah, delicious. Okay, watch this. Oh, okay, watch this. Oh. 6x, okay. I don't know what problem this is, but 6x squared plus 12x plus y plus 13 equals 0. Okay. So what you want to do? Well, yes, I know in the past I said that all quadratic equations should be equal to 0. In this one, they try to trick you. In this one, they put in a y and they put in a 0. So far we've been having y equals to, so we're going to solve for y. So all I have to do is subtract y from both sides. So, you know what, I'm not even going to do it. I subtract y from both sides, so that leaves you with equals to negative y. I cannot have a negative y as an answer, so I'm going to have to actually multiply by negative 1 or change the sign, whatever you want to do. Multiplying by negative 1 will make this a positive y. So positive y equals, but when I multiply by negative 1 here, I have to multiply by negative 1 here. So that means that I have to change the signs of everything. 6x squared times negative 1 is negative 6x squared minus 12x, you said it, minus 13. Okay, we're good now. Is this equal to y? So now we can forget about this. Alright, so now let's isolate the terms. Let's see, do I have a blue marker so I can like write en bleu and not just en bleu? No, you know what, let me finish this problem and then I'll see if I have a blue marker. So I'm getting tired of writing with black. Alright, so let's separate the terms. So when I separate the terms, I go here and I go here. Alright, so what do I have here? I have the x, the thingy being negative, the square term being negative, the coefficient. So I'm going to take out, what else do I know? That this and 12 have a common factor of 6. So I'm going to take out the negative 6. Okay? If I had only taken out the 6, then this would have remained negative. Try to understand that. So x squared plus 2x. No, this doesn't go here. Oh, you know what? Forget it. I'll just rewrite it again. I was supposed to write plus box minus box, so I'll do it over here. Oh, okay, that's what I was supposed to do. Okay, oh, and I wrote equal y. Well, you don't have to write equals y, but if you must, you can. Alright, half of the linear term, 1. Square 1. Now, watch out. So yes, I am going to also subtract the 1 from here, but not just the 1. Remember what I have outside here. So 1 times negative 6, I'm going to subtract 6. I hope you understand that. Alrighty, so now let's continue with this. Alright, so by doing that you create a perfect square trinomial which can be turned into a square binomial. What was the term that was squared? 1, right? And now negative 13 plus 6. That's negative 7. Right? And where is my sheet? What did I do with it? What was the problem I was doing? That was funny. 6. Oh, okay. So you end up, this is your vertex form of the quadratic equation. So let us analyze this. When you have your equation like this, like this, your y-intercept is the constant. Okay? Do not confuse the y-intercept when the equation is in standard form with this constant when the equation is in vertex form. Your vertex, okay, is negative 1 comma negative 7. And your axis of symmetry is negative 1, the line that chops the parabola in half. And now, of course, equal y. Okay, so shall I do one more so you get the hang of this? That's it. Alright, I'm going to attempt to do something that looks kind of like complicated. But hey, complicated is my middle name. I don't even know what problem is this. Okay, it says 1/2, and that's what happens when you don't really have the answers in front of you. Okay, 1 plus 4 equals to x minus 7 square. Oh gosh. Alright. So the first thing I know is that I have to solve for y. And so I'm gonna use the distributive property here. Or you know what? I don't even have to use the distributive property here. I'm gonna show you something. I can rewrite this, and I'm gonna have to go step by step. I can rewrite this left hand side as y plus 4, okay, over 2. Because in reality I'm taking half of this. So half of this. So multiplying by 1/2 is the same thing as dividing by 2. Or I could have just use the distributive property. So y times 1 is y divided by 2. 4 times 1 is 4 divided by 2. So that's why. Alright, now here it's because it looks easier for me. Look, I'm going to multiply both sides by 2. If I multiply by 2, remember, this is being divided, this whole thing is being divided by 2. So if I multiply by 2, then this is going to cancel. So that's exactly what I'm going to do. Multiply by 2, cancel. And now I have y plus 4 equaling 2 times x minus 7. Wait. Oh my god. It's not that bad. If I I'm solving for y, so if I subtract 4 from both sides, right? Look, let me subtract 4 from both sides. I get, can you see here? Yes. I get y equals 2 times x minus 7 squared, okay, minus 4. Because you're not going to be able to take away 4, like, you're not going to say negative 7 minus 4, because this thing has to go through a process of squaring. Got it? But anyways, regardless, watch this. This is already in vertex form. Look, sorry. Look, this is already in vertex form. The axis of symmetry is positive 7. And the vertex is positive 7 comma negative 4. Okay. So, now what do all this mean in terms of graphing? Well, it has an interpretation, And right now we're going to shift from doing the vertex form, which I hope you got it down packed, okay? Unless, let me see, you want to do one more? You want to do one more? Let me see, which one can we do? No, if you have any questions, you can ask me, make a comment so I can make more, or give you more examples, or we're done with this and we're gonna go into what's going on when you have this little vertex form. What does it mean to have an equation like this? All right, so let's shift to the paper. All right, so as promised, let's continue with this. So now we're going to be, actually, I don't want to be graphing. I might do a little bit of graphing, but we already went through graphing. So problem number 1 says, y equals negative x, que bruto. All right, so let's start again. Okay, so as promised, we're going to explore the graphs of the quadratic functions in vertex form. So here, look, it's already in vertex form. Now, in case you don't remember, the vertex form of a quadratic equation looks like the following. Let me see now. All right, it looks like this. Y equals a times x minus h squared plus k. All right, so let's see now. The vertex of this one is positive 1, comma 2. All right, axis of symmetry, the AOS, the equation is 1. All right, so we were able to determine all that from there. So now let's see, let's plot the vertex 1, comma 2. So where is 1, comma 2? Well, 1, comma 2 right here. Wait, what does it mean? Well, remember something, this is where the parabola is going to get chopped in half. So, well, let's see on the calculator, because we don't have time to start creating a table. So I clear, and I'm going to type the equation that is given to me. So y equals x minus 1 squared, okay, because it's a quadratic, plus 2. So look at what's happening. So the parabola never touches the x-axis. Okay, that's fine, because that's not what we're after. Now let's take a look at these points. Okay, let me zoom in. Okay, hopefully this is enough. So look where what the axis of symmetry is. Oh no, cabruto. Look at this 1, comma 2. All right. Now, is this a minimum or a maximum? Well, if the parabola is going this way, that means that this is the minimum point. So then the parabola has a minimum of 1, comma 2, the vertex. Got it? All right, let's sketch it just once. I'm not gonna do this all the time. All right, so I'm gonna sketch negative 1, comma 6. Negative 1, comma 1, 2, 3, 4, 5, 6, right here. Then 0, comma 3, okay, 0, comma 3, 1, 2, 3. This is the y-intercept. Now the y-intercept can be obtained if you could just multiply through and get the equation in standard form. I'm not sure if there's another way. If there's another way, I'll let you know later on, okay? All right, 1, comma 2. So I got it. Now look at this. The values, this is the turning point. The vertex is the turning point. The values of y start repeating over here. So I have 2, comma 3, so 2, comma 3. And then of course, 3 is gonna be 6. Okay, so I have my parabola right here. Okay, papam, papam, arrowheads. I label the equation if I have to. And now what? Now, let's notice something. The parabola, the original parabola, let's graph the original parabola. X squared, that's the parent, that's the OD nice original one. That's the original one. And now, what do you notice? The original one got shifted, okay? Got shifted 1 unit to the right. and got shifted 2 units up. What? Exactly. Always use the parent function. This is the parent function, the x squared. And then see how the other parabolas start behaving. So it got shifted 1 unit to the right and 2 units up. 1 unit to the right, axis of symmetry tells you that. And 2 units up. Yeah, right. Let's try another one. Okay, and this time I'm not gonna be graphing. Okay, this time I'm just gonna graph it on the calculator. So let's see now. I'm not gonna erase the parent function because we wanna see what the behavior is. So let's try a different one. Let's try this one. Okay, and let's see if it works. So my prediction is that it's going to, because the axis, okay, the vertex is what? -7, comma, -8, right? And the axis of symmetry is x equals -7. All right. So my prediction is that it's going to go 7 units to the left and 8 units down. So that's what vertex form does. Nice. So y equals, let me see now, -3 times, okay, then x plus 7 minus 8. So let's see. Look at that. The parent function is this one. Now, look at this. Let me change the window so we could see more of -y. Let's see if we could see more. No, we cannot see more. Okay, so I'm gonna change it again so we could see even more. Oh, duh, I changed the x, not the y, sorry. Y minimum. There you go. Ah, now we got it. And the parent function, of course. All right. So how did this graph change in relation to this function? Well, look at this. My prediction came true. It moved 7 units. Okay, 7 units. I don't know if you could see it. You want me to enlarge it? I could enlarge it. I don't have a problem with that. Okay. It moved 7 units to the left because that's where half of the parabola happens, and it shifted 8 units down. Yeah, but why is it looking downwards instead of like the parent function? Well, look at the a coefficient. It's negative. Remember, when a is negative, the parabola will actually open downwards, and it will have a maximum. See, when it opens up, it has a minimum. Down, it has a maximum. Okay? Okay? So let's take a look at another one. You see, I don't want to be sketching them if I can have the calculator. Okay, we already know how to plot points. I'm going to have the parent function right here and the other one right here. Anyway, what is your prediction about this graph? Okay, so let's graph. What? What did I do? What did I do? What did I do? What did I do? Oh, backs. Okay, clear? Clear. Okay. So that is the parent function. And now the one in red, it's gonna be the other one. Alright, so let's make this a little more convenient. Let's change again the negatives on the y, okay? So was it your prediction that it was going to actually that it was going to move well, okay, the vertex, it will be +2, comma 5. So right here you know that it will move, it will shift 2 units horizontally and 5 units up. I hope that was your prediction. And the axis of symmetry, the equation is x = 2. That's where it chops the line. Okay? Cool then. What else? Is the vertex a maximum or a minimum? Well, it's a minimum because it's the bottom point. Okay, and the minimum is right here. Okay. Here. Now here we're not gonna use the calculator. Here I want your prediction. What do you think is gonna happen to the parent function? Okay, the parent function is the one that starts at 0, 0, right? So what is it? Well, the vertex. Right. And the axis of symmetry. So the parabola will move what? 5 units to the right. So it will shift 5 units here, and it will shift also 3 units down. You're the beast. Yes. And now let's take a look at the some of these questions. So let's see. Remember what the parent function is. The parent function starts over here, okay, and it goes like this. So here, what happened to the parabola? It moved 2 units to the right, okay, because the axis of symmetry is positive 2, x equal 2, and the vertex is 2, negative 4. So 2 and then negative 4. So it shifted 2 units to the right and 4 down. How about, and wait, I wanted to show you something too. If A, this is A, okay, A, if A is a number greater than 1, the parabola becomes skinnier. If it's less than negative 1, it also becomes skinnier. For example, if this was a negative 3, this is a negative 3, then the parabola becomes skinnier. If this was a positive 3, it will still become skinnier. The thing is that anything greater, if A is greater than 1, okay, or if A is less than negative 1, okay, the parabola becomes skinnier. What's greater than 1? 2, 3, 4, 5, 6, 7, 8, 9, 10. What's less than negative 1? Negative 2, negative 3, negative 4, negative 5, negative 6. Alright? So that's what I mean. Now, if A is less than 1, okay, less than 1 but greater than 0, okay, so if A is between 1 and 0, the parabola becomes fatter. It becomes wider. In other words, if it's a fraction, it becomes wider. Whether it's positive or negative, it still becomes wider. Okay, got that? Just wanted to say that. All right, I don't know if I said it in the best way possible, but I did try. All right. So the behavior here, it will go 4 units to the left and it will go up 3 units. Yes? Oh, okay. Here, it will move what? Yes. And then it will, you got it. Okay, so you got this quadratic equation down pat. So the vertex is 1, 4, and the axis of symmetry is 1. Nice. Alright, 2 units to the left and it goes down 1 unit. So it does help you because when you have the vertex, okay, in the axis of symmetry, now you know where the values of y start repeating. They start making sense. Okay, having the vertex right here, all the vertex here, so I know that this is the turning point. Got it? Alright then. So that covers about everything from everything from quadratics. I did everything. Nice. Bex, if you have any questions, make comments. If not, then just I don't know, ask me, whatever. Bye till next episode of How Do We Pass Our Common Core Algebra Regions. And I got something for you right now.